So, in the last lecture we have observed that how to find out the Fourier series of a function and also how to find out the Fourier series of an even function or of an odd function. As you have seen, for the Fourier series of even function, then we have only the terms of cosine, and if the function f x is odd function, then f x can be expanded in terms of sine terms only. Now, let us take one more example to check how we can find out the Fourier series of a function. Let us take a function f x equals x, x lies between 0 to 2 pi and it is a periodic function with period 2 pi, that is f of x plus 2 pi equals f x. So, here your a naught I am directly writing a naught equals 1 by pi 0 to 2 pi f x dx, and if you calculate the value f x equals x in 0 to 2 pi, so that it will become only 2 pi. Your a n equals 1 by pi 0 to 2 pi f x into cos n x dx. What is x? f x equals x is an odd function. So, that this becomes odd. So, your a n is 0. Without calculation also we could have told. Your b n is 1 by pi 0 to 2 pi f x is x into sin n x dx. So, that this I can write down 1 by pi into minus x by integration by parts after doing x into cos n x by n, 0 to 2 pi we can write down minus 0 to 2 pi cos n x by n into dx. This is the second term. So, that I will obtain this equals 1 by pi minus x into cos n x by n here, and here I will obtain sin n x by n square, since here it is n is there and the limit will be from 0 to 2 pi. So, if I evaluate the limit of this, I will obtain b n, this is equals to minus 2 pi into cos of 2 n pi by n pi plus 1 by n square pi into sin 0. Sin 0, this term will be vanishing and this term will be cancelled, pi will be cancelled, this is 1. So, that you will obtain f x equals minus 2 by n, sorry b n equals minus 2 by n. So, that I can write down f x equals pi, because your a naught was 2 pi. So, a naught by 2. So, it will be pi minus summation n equals 1 to infinity b n sin n x, b n is 2 by n minus 2 by n. So, it is 2 by n into sin n x. So, if I expand it, I will obtain minus twice sin x plus it will be sin of 2 x by 1 minus 2 sin 3 x by 3, and like this way it will continue. So, once I am getting a naught, a n and b n, I can expand the function in this series. I hope it is clear to you now that if a function f x is given to us, then how to find out the value of the series for the function f x, and once I am representing f x in terms of a Fourier series, that is in terms of sine and cosine series, then at any particular point where the function is continuous, I can find out the value of the function also. So, let us see this thing. Just a naught, a n is 0, b n is this one, we calculating, and ultimately we are getting minus 2 by n. So, that f x is pi minus twice sin x minus sin 2x by 1 minus twice sin 3x by 3, like this way it will continue. Now, functions having arbitrary period. So far what we have done? We have dealt with Fourier series expansion of functions where the period is of 2 pi. But if it is of arbitrary period, what will happen? Means, in many practical problems and engineering problems, we have found that the function may have arbitrary period, not necessarily it will be twice pi. Or in other sense, I can tell in general that we can obtain Euler's formula for Fourier coefficients for the functions whose period is 2L. That is, we are trying to generalize now. Earlier, we have done it for minus pi to pi or for period 2 pi. Now, we want to check that if the period is a generalized one, 2L say, what is the effect on this, where L is some positive number. So, in this case, we are assuming that suppose you have f x function f x is defined in minus L to L. Since f x is defined in minus L to L and it is a periodic function with period 2 pi, to match with the earlier things, we are assuming this thing, say z equals pi x by L. So, that from here you can write down, from this you can write down your x equals L into z by pi. And also if you see, as x equals minus L, you have z will be equals to minus L. So, it will be minus pi, and whenever x is equals to L, then if you put z equals pi. So, basically if you see what we have done, we are making a substitution z equals pi x by L, and by this substitution we are changing the interval of the or the range of the function from minus L to L to minus pi to pi. Whenever I am substituting this z equals pi x by L, the limits also will be changing from minus pi to pi, and I know the formulas for minus pi to pi already. So, now I can write down, hence I can say that if I am creating a new function f of z, which I can define as f of Lz by pi, which is nothing but capital Fz is a function of x equals Lz by pi, and it is, you can say now, it is defined in now minus pi to pi. Once it is defined in minus pi to pi, so I can expand capital Fz in terms of Fourier series, because I know Fourier series of a function f x in minus pi to pi. So, once please note this one, I had the original problem f x which I was defined in minus L to L. I am making the substitution z equals pi x by L. By that way, your z is now moving from minus pi to pi. So, that my original problem f x is now I am replacing by a new function capital F z, which is nothing but f of L z by pi, and which is defined in minus pi to pi. So, that capital F z can be expanded in terms of Fourier series. So, I can write down capital F z equals a 0 by 2 plus summation n equals 1 to infinity a n cos n z plus b n sin n z, where you know a naught equals 1 by pi minus pi to pi f z dz, your a n will be equals to 1 by pi minus pi to pi f z into cos of n z dz, because I have to write down cos of n z, and b n equals 1 by pi minus pi to pi f z into sine of n z dz. So, now this f z I can replace by small f of n z by L, because your capital Z is nothing but function of z, this one is equals to your f of L z by pi. So, this now I can replace this whole thing by this. So, once I am replacing this, I can write down f of L z by pi. This is equals a naught by 2 plus summation n equals 1 to infinity a n into cos n z plus b n into sin n z, where a naught equals 1 by pi minus pi to pi. Capital F z now I am replacing by f of L z by pi into d z, your first a n 1 by pi minus pi to pi. Again capital F I am replacing by small f of L z by pi into cos of n z d z, and your b n, this will be equals to 1 by pi minus pi to pi f of L z by pi into sine of n z d z. And now you know. So, I am writing, before this I translated, I have written the Fourier series of capital F z. Now, in this slide you see I am transforming capital F z by f of L z by pi, and after this what I will do? I know that x equals L z by pi. If I substitute now this, so that your dx will become L by z into by into z. So, now this dz I can replace in terms of dx, and z I can transform in terms of x. So, if I do that thing by transforming x equals L z by pi and dx equals this quantity, then I can write down your f x equals a naught by 2 plus summation n equals 1 to infinity a n cos of. So, there was L z by pi, by substituting L z in terms of this, it will be cos of n pi x by L, because your L z by x equals L z by pi, L z by pi. So, putting the value of this n z was there. So, I am substituting this plus b n into sine of n pi x by L, where your a naught will be equals to 1 by L. Now, the limit will be changing, it will be now again from minus L to L, f x dx, a n equals to 1 by L minus L to L f x into cos of, this will become z I have to replace. So, that cos of n pi x by L dx, and your b n will be equals to 1 by L minus L to L f x into sine of n pi x by L. Therefore, please note this one, the earlier Fourier series whatever we have defined, that was for minus pi to pi. So, now if a function f x is defined in minus L to L, then f x can be expanded in terms of Fourier series as f x equals a naught by 2 plus summation n equals 1 to infinity a n cos n pi x by L plus b n sin n pi x by L, where a naught equals 1 by L minus L to L f x dx, a n equals 1 by L minus L to L f x cos of n pi x by L, and your b n will be 1 by L minus L to L f x sin n pi x by L. So, only change is coming here, here and here, limits are being changed from minus L to L, and this will be true for some value from C to C plus 2L I can write down. This formula is true whenever I take any function f x which is defined in C to C plus 2L. So, that whenever C equals minus L, it will be from minus L to L. I can make it 0 to 2L by making C equals 0 to C equals 0, I can put it this one. So, I hope it is clear. A generalized function, if a function is defined in a generalized period or arbitrary period with period 2L, in that case we can define it like this way. So, just as we have told here, we are making it z equals pi x by L. So, that x equals L z by pi. When x equals minus L, we have z equals minus pi. When x equals L, we have z equals pi. So, that now we are redefining the function in minus pi to pi as a new function capital F z equals f of L z by phi, and where we know that f z can now be expanded in terms of Fourier series, which is known to us. So, that f z can be written in terms of this, where a naught, a n and b n are these three quantities integrals. Now, substitute here f z value of capital F z is nothing but f of L z by pi, which we have shown in the last here. Capital F z equals f of L z by pi. So, once I am writing this, I will obtain f of L z by pi this, where a naught, a l and b n will be changing. Now, I have to replace z by x. So, that using the formula x equals L z by pi. So, that dx I can represent in terms of dz, and then f x can be written as a 0 by 2 plus summation n equals 1 to infinity a n cos n pi x by L plus b n into sin n pi x by L, where a naught, a n and b n are these things which are defined from minus L to L. So, only change is coming. Earlier, when the function was defined in minus pi to pi, it was simply cos n x. Now, it is cos n pi x by L or sin n pi x by L when the function is defined in minus L to L. And let us see, we have a function f x which is defined in the period in minus L to L with a period 2L. We want to find out the Fourier expansion of this function f x, which is defined in minus L to L. So, here f x is x. So, basically it is nothing but an odd function. Therefore, directly I can tell your a n will be equals to 0, your b n is equals to 2 by L, b n will be 0 for all n greater than equals to 0, b n will be equals to 2 by L into x sin n pi x by L into dx. If you evaluate the integral, this will be equals to 2 by L minus L x by n pi into cos of n pi x by L plus L square by n square pi square into sin of n pi x by L. The limit will be from 0 to L. So, if I substitute the limit over here again, the limiting values, your b n you will obtain as 2 by L minus L square into cos n pi by n pi, and which is nothing but your minus, if it is coming out, cos n pi. So, this will be minus 1 to the power n into this one. So, that no, this minus also will come outside, this minus is there, cos n pi is minus 1. So, that I can write it 2 into minus 1 to the power n plus 1 into L by n pi. So, that Fourier series of the function f x I can define as 2 by pi summation n equals 1 to infinity, n equals 1 to infinity minus 1 to the power n plus 1 into L by n into sine of n pi x by L. So, Fourier series of the function f x, I can f x equals x, which is an odd function, equals 2 by pi 0 to n equals summation n equals 1 to infinity minus 1 to the power n plus 1 into L by n into sine n pi x by L. Let us see this thing quickly. So, f x is an odd function n in 0 for all n including a naught. Your b n will be then from the formula 2 by L 0 to L x sin n pi x by L dx. If you evaluate the limit, you will obtain the value as this one, 2 into minus 1 to the power n plus 1 into L by n into pi. So, that Fourier series of the function can be written x equals 2 by pi summation n equals 1 to infinity value of b n. So, I hope it is clear how we are finding out the Fourier series of a function when it is defined in some arbitrary range minus L to L. Let us see this one. Earlier one, we wanted to find out the periodic function of the value of the function f x, Fourier series of the function f x when f x equals x. Now, we have provided with f x equals x square. So, since f x equals x square, this is even function. So, that there will be only terms of a naught by 2 and a n. So, f x can be represented as a naught by 2 plus summation n equals 1 to infinity a n, only cos term will be there, cos of n pi x by L. Now, your a naught is equals to 2 by L into 0 to L x square dx. If I evaluate it, 2 by L into this will be x cube by 3 0 to L. So, you will obtain L cube. So, 1 L will be cancelled, 2 L square by 3. So, your a naught is becoming 2 L square by 3 and your a n is equals to 0 to L x square cos of n pi x by L dx. So, this one I have to break it into two parts. So, that I will obtain my a n, I can write down as 2 by L. This calculation will be little complicated, sine of n pi x by L divided by, then it would be n pi by L minus twice x into minus cos of n pi x by L. So, it will be n square pi square by L square plus there will be another term 2 into minus sin n pi x by L and another time multiplication. So, this was n square pi square, this will be n cube pi cube by L cube and the value will be from, limit will be from 0 to L I have to put. So, if I evaluate this one, I will obtain 4 L square into minus 1 to the power n divided by n square pi square. I will obtain this. So, that your a 1 will be equals to minus 4 L square by pi square. Your a 2 will be then 4 L square by 2 square into pi square. Your a 3 will be again minus will come minus 1 to the power 3. So, it will be 4 L square by 3 square into pi square. In this way it will go. So, that you can write down your x square, this is equals to L square by 3 minus 4 L square by pi square. This will be in common into cos pi x by L, cos pi x by L 1 square minus cos of 2 pi x by L into 2 square plus cos of 3 pi x by L by 3 square minus, like this way it will continue. So, therefore, if x square is defined in this range, then the x square can be expressed in terms of Fourier series like this way. So, just let us see quickly again whatever we have done. Since f x is even function, it will consist of sine terms, cos terms only, a naught and a n will be there. A naught is this 2 L square by 3, a n if you calculate 4 L square minus into minus 1 to the power n by n square pi square, and a 1, a 2, a 3 are these. So, that x square you can write down in this term like this way. Next problem, let us see quickly again. A function is given with a period 2, where f x equals 1, x lies between 0 to 1 and 2 for 1 to 2. Let us see f x equals, we are not able to tell it whether it is even or odd. So, that f x can be represented as a 0 by 2 summation over n equals 1 to infinity a n. Here it will be period is 2. So, that L is equals to 1. So, that it will be a n cos n pi x by L will not come, because here value of L equals to 1. Basically, the function is defined from 0 to 2 plus b n into sin n pi x, where your a naught will be 0 to 2 f x dx, and the function is 0 in 0 to 1. So, that basically 0 to 1 it is 0 to 1 it is 1 and 1 to 2 it is 2. So, I have to break it into two parts. 0 to 1 f x is 1 plus 1 to 2 it is 2. If you evaluate the value, you will obtain this is equals 3. Similarly, a n equals 0 to 2 f x into cos n pi x dx. This equals, you can write down 0 to 1 cos n pi x dx plus 1 to 2, the value is 2. Therefore, it will be 2 into cos n pi x dx. If you evaluate the integral, you will obtain value of both the integrals as 0. Similarly, your b n is equals to 0 to 2 f x into sin n pi x dx, which you can write down 0 to 1 sin n pi x dx plus 1 to 2, 2 into sin n pi x dx. And if you evaluate the integral of this is actually your 0 to 1, 1 to 2. So, that I am just writing this minus cos of n pi x by n pi 0 to 1 plus 2 into minus cos n pi x by n pi, this will be from 1 to 2. If I evaluate these values, you will ultimately obtain 1 by n pi into minus 1 to the power n minus 1. So, that I can write down b n, this is equals to 0 when n is even, and this is equals to minus 2 by n pi when n is odd. So, once I have obtained this, a naught I have obtained, a n I have obtained, a n is 0 and b n I have obtained this. So, I can write down f x equals 3 by 2 minus 2 by pi into sin pi x by 1 plus sin of 3 pi x by 3 plus sin of 5 pi x by 5, and like this way it will go. So, the function f x can be represented in this particular format. Therefore, if a function f x is defined either in minus pi to pi, either in minus L to L, or if it is an odd function, or if it is an even function, we can find out the Fourier series of these functions like this way.